In 2003, two robots named Spirit and Opportunity were loaded onto a pair of Delta II rockets. The rockets blasted off separately about 3 weeks apart. 7 months later, the pods arrived, streaking through the Martian atmosphere, containing perhaps the most complex and advanced robots ever created. The rovers were powered up, stretched their legs, and made contact with their controllers on Earth to begin their long missions on the Red Planet. Today, we're proud to share our newest creation, the Spirit Rover, a desktop version of the famous rover sent to Mars. Our miniature version of the real thing is built around a Raspberry Pi computer and includes an Arduino-compatible processor along with a ton of sensors and smarts. Whether you're new to programming or an experienced pro, Spirit is a perfect robot platform for learning to program in Python and C, as well as learning the inner workings of the Linux operating system. Tutorials and lessons will guide you along the way. You'll code and control your own rover missions while learning how computer vision and autonomous robots work. Remote control your missions using Wi-Fi from a computer, tablet, smartphone, or a game controller. Spirit is an ideal platform for teaching in classroom environments, playing on your own at home, and even used in serious research. We've combined the most common pieces of hardware available in the open source and maker community into a single robot that's endlessly hackable and expandable. Not only is Spirit a practical robot for learning, he's also loaded with personality. He has a pan-tilt head to look around and tell you how he's feeling. 27 NeoPixel-style lights can be individually controlled to create any color sequence you can think of, and a piezo sound chirper can create blips and tones. These are the droids you're looking for. The Raspberry Pi camera can be used for computer vision. This is an exciting new field in robotics. Spirit can identify objects, colors, movement, and even faces. The rover includes a gripper along the front, suitable for moving and collecting small objects. Spirit can see the gripper and object with his camera, so remote controlling and computer vision operations are possible. Spirit includes several useful navigation sensors in addition to the camera. The eyes are actually an ultrasonic rangefinder that measures distances to objects. The main board also includes a 3-axis accelerometer and gyroscope. These sensors can be used to move specific distances and make accurate turns. An array of bottom sensors are also provided that can be arranged in various patterns. The sensors can follow lines or sense edges. You can also enable an emergency stop, where the motors will automatically stop if the robot's about to fall off an edge. 3 ambient light sensors are provided to measure light 360 degrees around the robot. We've also included a port to add an optional LED headlight or infrared emitter for communication or navigation in the dark. Spirit is actually 3 computers in one. The Raspberry Pi at the heart of the rover will handle most of your code and processing. The Arduino-compatible processor on the rover's main board can be used to run code by itself or used together with the Pi. The third processor is a microchip PIC processor. It's preloaded with code and handles low-level tasks in the background. You can hack it too if you like. All 3 processors communicate with each other using simple functions, allowing you to effectively control any of the robot's hardware and sensors in almost any conceivable combination. This is truly a hacker's dream robot. You can communicate, upload code, and drive the rover remotely from just about any computer or smartphone using Wi-Fi or Bluetooth, including common 6-axis type game controllers. You can even program and remote pilot the robot over the internet. Use Wi-Fi or Bluetooth built onto the Pi, or add your own module to the main board for Wi-Fi, Bluetooth, and even XBee for Zigbee mesh networking. The robot is powered by a single-cell battery with a runtime of 1 to 4 hours. Automatic charging is built right in. The robot can be powered or charged from a USB cable connected to your computer or an optional external wall power supply. We should also point out Spirit's high-quality components. The micro gear motors are precise and allow the robot to run on a variety of surfaces. The plastic frame parts are made from semi-flexible ABS plastic. The parts are not brittle, so you won't have to worry about them cracking. The rest of the hardware includes durable parts stamped from metal, striking a good balance between lightweight and durability. You'll assemble Spirit yourself from a kit using common hand tools. No soldering is required, and we'll provide illustrated instructions to make the process easy. Spirit is a great solution for so many applications, from basic remote control toy, to learning simple and advanced coding, to learning how autonomous robots work at a deeper level. You're not going to get bored with this robot anytime soon. Easy access is provided to connect to monitor and USB devices. You can use the Raspberry Pi inside the Spirit just like you would a normal standalone Pi. All the important signal lines and ports are exposed so advanced users can add on to the robot or use the electronics on their own custom robot frame or chassis. We'll guide you along the way through written guides and tutorials along with examples you can customize on your own. For the past 2 years, we've been creating an ecosystem of robots and guides to teach programming. Continuing with this effort, we also plan to launch a YouTube series covering all kinds of tutorials and inspiring examples for Spirit and our other robots. This project is not officially endorsed or affiliated with NASA, JPL, or any of the agencies related to the actual Mars missions, but I am a huge space nerd. This project is a salute to the extraordinary engineers at Jet Propulsion Laboratory, NASA, and the rest of the world's space agencies. By backing this project, you'll help us buy parts in larger quantities and cover the tooling costs for Spirit's custom parts. You'll also help educate and inspire the Rover designers of the future. We'll add another awesome robot to our lineup and continue in the spirit of the open source movement to share and freely educate. Thank you for your time, and thank you for your support. Hey Kickstarter, I'm Kevin. Thanks for watching. This is our 4th Kickstarter, and this is the coolest thing I've ever designed. I'm really excited to have you all on board. If you're a returning backer, you know that we like to cover a lot of the behind-the-scenes details on our projects, and there's a lot more to this one than our other projects. So if you're into that sort of thing, I think you're really going to enjoy watching this one play out. We've become good friends with a lot of you, and it's because of you all that we're able to keep coming out with these fun projects. We're just a few creative people working in a small shop outside of Portland. It's nothing fancy, but we have a lot of fun. We hope you'll back our project, and we welcome you to join us on another great adventure. Thank you.